Kubernetes and GKE Part 35. This episode has 3 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain ephemeral containers. Here's a strong way to approach it. Ephemeral containers in Kubernetes are temporary containers that you can inject into a running pod for debugging purposes without restarting or modifying the original application container's core idea. Ephemeral containers are debug containers added to a live pod to inspect or troubleshoot issues safely. They are not part of the normal pod spec lifecycle. Why ephemeral containers are used? They help you debug production issues without downtime, inspect running containers when kubectl exec is not enough, troubleshoot minimal or distroless images. No shell inside container. Avoid restarting pods just for debugging. How they are different from normal containers added after pod is created. Do not restart pod. Do not affect pod spec. Exist only temporarily. Cannot be updated once created. How it works. 1. Pod is running normally. 2. You inject an ephemeral container into it. 3. Container shares the same network namespace. 4. You use it to inspect or debug other containers. 5. It disappears when pod is deleted. Example command kubectl debug it pod or my pod. Image equals busybox. Target equals my container. What happens internally? Kubernetes adds ephemeral container spec via API. Kubelet starts the debug container. It joins the existing pod namespaces, network, process, etc. Example use cases. 1. Debugging missing shell if app container is minimal. No bash or sh. Distroless container. No shell. Cannot use kubectl exec. Use ephemeral container instead. 2. Network debugging kubectl debug pod or my pod it. Image equals Nicolica or Netshoot. Then run curl pings lookup. 3. Inspect file system or processes. Check mounted volumes. Inspect running processes. Validate configs. Ephemeral container properties. Shares pod namespaces. PID. Network. Cannot expose ports independently. Cannot restart pod. Cannot modify original containers. Only for debugging. Example YAML. Conceptual ephemeral containers. Name. Debug container image. Busybox command. sh. Target container name. App container. Kubectl exec versus ephemeral containers. Feature kubectl exec. Ephemeral containers works if shell exists. Yes works in distroless images. Cross mark no, check mark yes. Requires container restart no added to pod spec no yes. Temporary purpose command execution. Full debugging environment. Simple analogy. Think of pod equals running car. Kubectl exec equals opening driver door to check dashboard. Ephemeral container equals attaching a temporary mechanic workshop to the car while it is still running. Limitations: cannot be used in all clusters by default. Feature gate in older versions. Cannot modify pod state. Not suitable for production logic. Requires RBAC permission. Pods or ephemeral containers. Best practices: use official debug images. Netshoot. Busybox. Remove ephemeral containers after debugging. Use instead of SSH like access. Combine with logs for faster troubleshooting. Interview ready. Definition: ephemeral containers in Kubernetes are temporary debug containers that can be injected into a running pod without restarting it, allowing administrators to troubleshoot live workloads by sharing the same namespaces as existing containers while not being part of the pod's original specification or life cycle. Nice. Let's continue. Question 2. What is topology spread constraint? Here's a strong way to approach it. Topology spread constraints in Kubernetes are a scheduling feature that controls how pods are distributed across failure domains like zones, nodes, or racks to improve availability and balance. Core idea: topology spread constraints ensure that pods are evenly spread across different topology domains, like zones or nodes, instead of being concentrated in one place. Why it is used: they help to improve high availability, avoid single point of failure, balance workload across zones or nodes, prevent resource hotspots, support multi-zone resilience. What is a topology domain? A topology domain is a grouping of nodes based on labels like zone, e.g., us-1a, us-1b, node rack region. Custom labels. How it works: Kubernetes scheduler tries to ensure number of pods per topology domain equal distribution. It compares desired spread actual distribution constraints defined in pod spec. Example YAML API version v1 kind. Pod metadata name my app spec. Topology spread constraints max skew 1. The exact commands and code are in the written question bank. Great. Moving on. Question 3. Explain multi-cluster Kubernetes. Here's a strong way to approach it. Multi-cluster Kubernetes refers to an architecture where multiple independent Kubernetes clusters in Kubernetes are used together to run and manage applications as a unified system core idea instead of one big cluster. You run multiple clusters and manage them together for scalability, reliability, and isolation. Each cluster is still independent, but they are operated as part of a single platform strategy. Why multi-cluster Kubernetes is used? It solves problems that a single cluster cannot handle well. High availability across regions, disaster recovery, reduced blast radius, failure isolation, multi-cloud deployments, AWS plus Azure plus GCP, compliance and data residency requirements, scalability beyond one cluster, limit how it works, high level, global control or management layer, cluster A, cluster B, cluster C, AWS, Azure, GCP. Each cluster has its own API server, runs workloads independently, can be in different regions or clouds. Key characteristics: 1. Independence. Each cluster is self-contained. Failure in one does not affect others. 2. Central management. Optional. You can use tools to manage them. GitOps tools, Argo CD, Flux, service meshes, Istio, Linkerd, cloud tools, GKE Hub, XFleet, Azure Arc. 3. Distributed workloads. Apps can be deployed per region, per environment, dev, staging, prod, per tenant or customer. Multi-cluster use cases. 1. High availability. If one cluster fails, traffic moves to another. 2. Disaster recovery. Backup cluster in another region, failover setup. 3. Global applications, users routed to nearest cluster, low latency. 4. Multi-tenant isolation, one cluster per customer or business unit. 5. Compliance. Data stays in specific country or region. Traffic management. In multi-cluster, you can route traffic using global load balancers, DNS-based routing, service mesh, Istio. Multi-cluster, cloud provider routing, Route 53, cloud DNS, Azure front door. Multi-cluster Kubernetes versus single cluster feature. Single cluster, multi-cluster complexity, low high fault isolation, limited strong scalability, limited high global reach, no yes management overhead, low higher simple. Analogy: think of single cluster equals one large factory, multi-cluster equals multiple factories in different cities, coordinated to produce the same product. If one factory fails, others continue working. Key challenges: 1. Operational complexity, more clusters equals more to manage. 2. Networking complexity, cross-cluster communication is difficult. 3. Consistency, keeping config synced across clusters. 4. Observability, harder to monitor multiple clusters together. Tools used in multi-cluster Kubernetes management: Argo CD or Flux, GitOps, Rancher, Anthos, Google, Azure Arc, AWS, XFleet Manager. Networking or service discovery: Istio, Linkerd, Submariner. Best practices: use GitOps for consistency, automate cluster provisioning, centralized observability, Prometheus plus Grafana. Standardize cluster configurations, define clear failover strategies. Interview-ready definition: multi-cluster Kubernetes is an architectural approach where multiple independent Kubernetes clusters are deployed across regions or cloud providers and managed together to achieve high availability, disaster recovery, scalability, and isolation while enabling distributed application deployment and centralized or federated management. Alright, next question. That wraps up this episode. Nice work practicing, and see you in the next one.